What's up, everybody? Welcome to your latest installment of Nuclear Barbarians. It is I, your nuclear barbarian, Emmett Penny, and I am here with Darius Mortazavi. And I'm stoked to talk to this guy because he knows stuff about stuff that I don't know anything about, which is my favorite type of guest to have. Darius, welcome to the show.
So much. No, I'm real excited to be here. Appreciate you.
Yeah. So I found out about you through, we both run uh sort of, are you daily over at the column?
No, actually, I'm 3 times a week, but
So you're
I
three times a week.
previously attempted 5 times a week, but that didn't pan out for me too long.
Yeah, it's a grind.
Oh
But
yeah,
you run another sort of like industrial oriented newsletter, the column, which is great. Everybody, by the way, all this stuff is going to be in the show notes. Subscribe to Darius's work. And you've now started to branch out into something that is a little bit more your own called Feedstockland, which is a
that's right.
Substack. So before we get into Feedstockland and all that, who the hell are you, man? What's
Well,
your
cool.
background? How'd you get into this stuff?
No, I mean it is kind of weird to end up like in the internet scene of talking about industrial stuff. So
Yeah.
it's always worth the story. The real short version is basically that I was studying chemical engineering. I did the sort of internships that people did, but I got really fixated on like when I would ask, say, my manager, like where that stuff was coming from, or like why are we getting ExxonMobil's propane? Like what? Like and who's there's like all this other stuff. It's all connected, and it was frustrating me that when I would ask questions, people wouldn't know because they were just like very simple questions. At some point, they like basically they sent me downtown to go meet with someone that was like at the headquarters. And so I asked that guy a ton of questions, ended up interning with his group the following summer. And when I was there, I basically just like, met all these old people that basically know a lot about the industry, right? I mean, it's
Mhm.
it's the chemical industry, so it's a little old in some sense.
Yeah,
And
a
yeah,
lot of gray beers out there.
for sure. I mean, but that means like lots of long lunches and like stopping by people's cubicle for an hour, like things like that. And you do enough of
Yeah.
that, you get enough context. And basically one thing led to another, and I wanted to stay up to date with the stuff, but there was no way of staying up to date. So I built this like web scraper to go and pull news for me, like just a Python scraper basically. And at some point when COVID happened and I realized, oh, I've got like a couple extra hours a day because I'm no longer walking around campus, probably should do something with this scraper. And I was really inspired by Morning Brew because it's kind of what got me like reading and stay up to date with news. And so I
Mm.
wanted to do that for the chemical industry. And when I looked around, I realized that like nobody else was going to do this. And so I started doing it, kind of on the basis of who knows what will happen. There's doesn't seem like there's any real downside. But yeah, that's what I'm doing. That is what the column became. And now it's been almost 3 years. So around this time 3 years ago, I was like starting to like get it going.
Yeah. Wow. Wow. I'm sure you've seen some great growth in that amount of time too. Because like you said, no one else is doing that. Like I know I learn a lot from the posts of yours I've seen from the column, and I'm not even anywhere near inside that industry. And so it feels like that's sort of what it seems to me like the column is very like inward focused on the
Mm-hmm.
industry. Like if you're in the know, you might need things just boiled down for you, but that's because you're reading this on your commute. That's what's going on there. Feedstockland has a totally different vibe. So why don't you tell me like what I'm always interested, right? Because I have this nuclear barbarians thing, obviously, tell by my background. People who are just listening to this on audio, the background's sick, you're missing out.
Super
Um,
cool. First thing when I first met you, you had that as your background's first comment I made was like, that is sick.
Yeah, that was done by my buddy Sterling Bartlett, who's a comic book artist in California. And I was like, "Can you do Iron Maiden's Power Slave, but a nuclear power plant?" And he was like, "Totally."
Absolutely.
Yeah, he's like, "Absolutely." But I'm always sort of interested in like you get into this stuff, and then you realize there are more things you want to say to different types of people.
Yes.
And that seems to be what's happening with Feedstockland to me. So why don't you first of all, great title for the Substack. Why don't you tell me about Feedstockland and what it's all about?
Yeah, absolutely. Well, Feedstockland is sort of born out of this like 3 year pent up. I've been writing about the industry, but in a bottle, right? So I
Mm-hmm.
I am addressing with the column, I do write it in third person. I am just trying to boil things down so they're easily understood. The motive there really is to give, people in the industry something to talk about, like news to discuss. But like, it's one thing to have topics and stay up to date, right, and give some context for what's going on. But it's really hard to like have a really good discussion about that stuff if you don't know the history, like the deep stuff too. Because it's so basically, Feedstockland is the result of I've wanted to say these things for a long time. I realized at this point that I can do that, and it's the goal of it really is to sort of take a look at the entire like chain of where stuff comes from and sort of elucidate like the parts that are the material aspects. So that ends up touching a ton of stuff. It's going to end up being like very heavy sustainability, but broadly speaking, it's just trying to make it a lot more clear, like where everything's coming from and why we should care about that.
Yeah, I love that because I think you have a similar instinct. To me, though, you have a way better technical background than I do, right? Like I studied poetry and then I got a master's in the classics. Like
That's technical.
yeah, I'm not the typical guy that ends up over here. But, I was always like, no, like, why did we stop building nuclear plants? And somebody would
Mm-hmm.
be like, reason A. And I'd be like, that's partially true, but nothing's monocausal. Like, why did we stop? Until I got to the point where I was just like, oh, these problems were happening with the alloys they were experimenting with. They had inherited from the Air Force and put into their turbines, and it started to create over. I was like, all right, now I'm getting the level of specificity where I can be like, this is what is going on. And it feels like you're trying to give the audience that for Feedstockland.
Right. No, I
Maybe
mean
not like
that's
historically, but like materially, that's what you're trying to offer.
yeah. I mean I guess so. I don't, have you heard of um the the idea that basically you can play like infinite games and indefinite games. So
No,
like
tell me about this.
the column is to me there is like an objective and audience, and I know what I'm doing and I have a goal with it.
Hmm.
Feedstock Land is a lot more exploratory. Like I'm
Mm,
I'm just going to write what makes the most sense to write for now. Like whatever direction that goes in, we'll see. It may end up being very heavy history. Like history might be a component in most of the pieces. I don't really know. I think history is fascinating, and the industry is so old and undocumented that
hmm.
there's a lot there to
Dude,
talk
yeah.
about for sure.
Dude, for sure. Like anytime you get into this stuff, you're like, damn, there are like for real gaps in the archive.
It's infinite. It's
Yeah,
infinite.
yeah, it is infinite. Yeah, it is infinite. Like its breadth is like asymptotically infinite, and then its depth feels like actually just time-wise, totally infinite. There will never be the history, there will only be histories.
Right.
Like that's where it has to go. So why don't you tell me about this piece? This is your inaugural piece that you've written
Yeah.
for Feedstockland called Visible Emissions and Invisible Problems, which I really liked. And it sort of gets into some basics about, well, we just need stuff. So why don't you tell me about like what the impetus for this piece was as your first one? Like, why is this the piece you had to write to launch Feedstockland?
Yeah, no, I mean, I think it's actually partly inspired by, Doomberg recently popularized the oxidation ladder.
Mm,
I had heard about it, read about it on these like weird chemistry websites before, but the first time I like saw something written very well about it was what he said. And I think that this sort of concept of like energy, like how much energy is required to do different things, like is sort of one of the chemical industry's toughest things to get over.
mm,
And I think that basically addressing the energy piece first made sense because it's what we see. And I wanted to be able to connect it to something that we do see. And so that's what I mean by the visible emissions, right? Like when you go and you're driving around industrial sites and you see like these giant, like, there's like these like wispy clouds down below, and there's like these giant billowing clouds that are like
mm-hmm,
spewing stuff, right? And it's like, oh, what is that stuff, right? And even me, like having, studied chemical engineering, right? Like first internship I'm like driving by these plants, and our reliability manager is driving us to like a dinner or something. And like I don't know if it was me that asked it or somebody asked it, right? Like, what is that? And he was like, oh, it's just water vapor emissions. And I remember thinking like, oh, no emissions, it's all good. It's just water vapor. People are freaking out, right? Just like immediately apologetic of the industry. And
Mhm.
he didn't mention that there's like CO2 and other stuff in there too, and like any of the complexities. And I just felt like if I was confused about that, like we probably need to get clear on that with everybody.
Mhm.
And
Mhm.
it's just a good sticking point for everything else you might want to talk about, right? Because those emissions like are illustrative of the actual like problem, which is like heat intensive energy driven processes, or sorry, heat driven energy intensive processes.
Right, right. And so I think like, well, you said something really interesting. You said like it's something that the industry itself struggles to get over. Like almost to, did you mean almost to explain to people or what? Like what does that mean?
The industry, I'm sorry, I didn't follow
No, no,
that.
no. So you said that like when it comes to these intensive energy processes and the emissions they create, like this is almost like a stumbling block or something for the industry. Is that in
Oh,
terms of like its public facing like explanation of itself or something that they're trying to solve because of climate
oh
policy
yeah,
or what's going on? I'm assuming it's like a little column A, a little column B, but why don't you just give me the
definitely.
flavor of it?
Yeah, the sense really is just that a lot of industries say if you want to, if Apple wants to decarbonize, right, like you just, you have to have power, right? It's just electricity, supply
Right.
electricity, buy power purchase agreements, right? It doesn't work like that for the chemical industry. If you want to make chemicals, you need to like actually input the energy directly, and you can't just like hook up a solar plant to it. Like it doesn't work.
Yeah.
You need to actually like the fundamentally the reason these reactions work is that they are driven by heat. It doesn't have to be that way, but that is how we do it. And so yeah, I mean basically you have to get over this energy requirement in some way or another. And right now we tackle with heat, but that's where a lot of this emission comes from, right? It's the burning of
Right.
hydrocarbons and right.
Yeah, and so I think there are a couple things that are sort of like happening in my mind when I read your piece. On the one, you're always confronted with the physical limitations of the industrial world, right? Like modernity
Mhm.
feels old now. Like a lot of these companies are like 3 century companies now. They've been here in the
Oh yeah,
19th, 20th, and 21st century. It's not, it ain't no spring chicken in the game, you know? And so people have invested in all of this physical capital, and it's
right.
hard to swap stuff out. And at the same time, it seems like there's a pressing need for alternatives. So let me ask you sort of maybe a dumb question, right? Really simple, which is
Okay.
uh, you said that it doesn't have to be that way, but it is
Mm-hmm.
the way it is now. So like the way it is now, I'm guessing is like petrochemical involved. That's something you say in the piece. Can't really
Yep.
get away from that at the moment. How could it be?
Yeah. I mean, so I think a good example is like what I'm basically hinting at here is that you don't have to drive the process with heat. You could drive it with electricity. This is
Mm,
not going to be the solution for every single right industrial process out there. It will work for some better than others. And at some point, like it's about how quickly things can be rolled out. But like we've been operating electrically driven processes for, I mean, at least over a century, probably a century and a half. I don't know whether the chlor-alkali process started like the late 1800s or early 1900s, but the way we make chlorine and caustic soda is has always been the electrolysis
mhm.
of brine. And I think that this sort of thing, it's not like intangible. Like we can produce chemicals in different ways. It just doesn't really always make sense to just zap stuff with electricity. Like that does not actually apply in every single
Yeah,
case. So
right.
yeah,
It's not just because it would be expensive or inconvenient, but because that's literally irrelevant to the industrial process involved, right? Is that what you're saying?
yeah, it's a bit of both. It's a bit of both.
Yeah, bit of both, bit of both. Yeah. Yeah, I mean that's another thing that you mentioned, which I thought was great. It's sort of like everybody's trying to strike this balance between like what's efficacious, what's affordable, and then like what's within their actual technical ability to
Yeah.
achieve. What are the discussions within the industry about that?
Ooh, discussions within the industry about it. Well, I think that I mean, I basically I see a few things. The big companies, right, like Dow Chemical, I see them
Mhm.
making multiple bets. They're pushing small modular nuclear, or at least they're like working with somebody on that.
Mhm.
Um, like I also see them up in Canada trying to use hydrogen to burning hydrogen as a heat source instead of strictly burning natural gas. I mean, they're doing those two. There's one more. I'm dropping it now, but basically they're trying a bunch of different ways of decarbonizing, right? Oh, sorry, it's like carbon capture, right? So
Oh yeah.
you basically you burn and then you capture the carbon, right? Those are the three that they're trying, and those are probably makes sense for them to do those things. I just hope that they're like also in the mood to snatch up any sort of startup that's developing technology faster, right? So that way there's there are alternatives in that, but I mean the alternatives really are limited to electrochemistry or yeah, I mean that's kind of what it boils down to at the end of the
Right.
day. Like you either burn something that doesn't produce CO2, you capture the CO2 you produce, you or I mean you could do a totally different reaction too. I mean we kind of go up and down like on the energy ladder a bunch of times to make chemicals. Like you
Mm-hmm.
could probably take a different route.
So you're saying you could use even more of what you're creating because there's always some sort of byproduct that comes out of this.
Yeah,
And that would be in part a solution. Maybe not like
yeah,
a
no, you
total
could
solution, but it would be helpful.
in a way. I think the crux of it really is that like we need this stuff, and if you want to get that stuff you have to start from something, and I think that and eventually demonizes things like oil and gas, but there's nothing wrong with using petrochemicals in itself. It's really more
Mm-hmm.
that where it ends up, right? So back to the whole plastics discussion and like where does is this are all of these materials just being piling up somewhere? Is that a problem? To what degree is that a problem?
Mm-hmm.
All that.
Yeah, yeah. So what do you see like whenever somebody starts communicating on something, I assume that they see that there's some sort of need to be met. Something isn't to their satisfaction in what's or how things are already being talked about. So what is that true for you? And if so, what do you think needs to be corrected in the discourse around chemicals and energy?
Yeah, no, that's a great question. I mean, the most like the example I see most frequently is discussion about hydrogen. Um,
Hmm. Dude, yeah, my
there,
timeline is blowing up with hydrogen these days.
it's a
I've even had
it's
like a couple friends be like, what do you know about hydrogen? And I'm like,
yeah. I mean, I forget where I got it from, but there's the way I like to think about like uh, how to break down the uses of materials is,
Mhm.
are we using that material for its fuel value or its material value? And
Mm,
so with hydrogen, right, like you hear about green hydrogen, right,
mhm,
producing it with electrolysis and so on. That sort of hydrogen, it's generally speaking, it's lower quantities. That works. That makes sense for producing fertilizer, right? You need hydrogen to produce fertilizer. If
mhm,
you don't get it from electrolysis, like you're not getting hydrogen. And
mhm,
so you for things like that, right, where you have a material application, hydrogen makes sense. Hydrogen probably doesn't make sense to propel trucks, right? But someone who produces hydrogen and delivers trucks with hydrogen probably wants their trucks to be powered with hydrogen, right? Like
yeah.
there are things like this that are really confusing to people. Like, why is this big company pushing hydrogen? Like, it's not that hydrogen doesn't have applications or that we shouldn't develop it or do any innovation in that space. It's just that it doesn't always make sense. And being able to detect that isn't easy. Um, and it actually requires like research and thinking, right? And it's not like
Mm,
you're we don't learn enough in school, and people generally speaking in other industries just have no line of sight to like chemicals, and it's a whole big hodgepodge of words that doesn't make any sense to people.
yeah.
And so there's just like a very large communication gap that's always been there. No one is
Mhm.
taking this information and making it easy for the broader educated community to read up on. It's just too hard to sort through that stuff, and I personally end up sorting through a lot of it, and so it just feels natural to lean into that stuff.
Yeah, I think that's really, when I was studying philosophy in grad school, I used to work at a Gold's Gym as a personal trainer. And
Nice.
if ever there was a really difficult book I was reading, let's say I'm reading Hegel, and I was like, how would I explain this to the guys in the back office at Gold's? Because that's how it would clarify it for me. Like I would have to be
Yeah.
like very precise and like very clear, no ums or uhs or anything like that. It's just how would I do it with them? And that's the feeling I got while reading your thing. Is I was like, oh, this is for somebody like me who's curious, but really doesn't have facility with this. And you said something really interesting in the piece. I think you said what you're trying to do is help your audience to develop like an intuitive sense of
Right.
whether or not a claim about the energy realities around chemistry makes sense.
Absolutely. Yes. I mean, it is a lot about developing intuition. And I mean, so the next piece is a sort of like a next level on top of the oxidation ladder that is talked about in this first one. Because these sort of mental models, like ways to think about stuff, are really important. Like we need taxonomies for having discussion. We need people to be all familiar with the same mental model to like immediately jump past it. Like we can't be explaining to every single person like over and over and over like how we need energy to make, like why certain reactions require energy. Like that needs to be something that's quickly understood so we can move on, right? In building that intuition for those sort of things, it makes sense because I mean I think the example, I actually don't remember how much detail I went into it, but the one I think about a lot is fire, right? Like we're all familiar with like a campfire, right? You If you want to get this fire started, you have to give it a little heat, right? But once it's going, it keeps going until it's out, right? That reaction releases energy. Um, and that's intuitive to people. What's not intuitive to people is that like some reactions just require constant energy input because we don't see that in our environment. Like our environment is oxidizing. And so that's what we do here, right? We don't do the opposite reaction out in the open air. Like what's the mysterious part of chemical reactors is that's actually going opposite. And it's the whole thing. You can develop intuition for it, but it does need to be written out in nice chunk sentences, right?
Yeah, no, absolutely. I think that's absolutely true. Like, yeah, I've thought about this a lot with like balancing the grid, where I was like, if something has like is non-dispatchable and has a low capacity factor, I was like, you think about it like a coin toss. Is that going to reconcile close to 100% of the time? And can you make it reconcile? And if the answer is no, then you need something to support it. It
Yeah.
can't work
I
on its
mean,
own, like, and that's only because, again, it's the back office at Gold's Gym. I needed that explanation too, like I needed a
definitely.
mental model for how this was going to work.
I mean, in a way, like it's not these mental models aren't like written out, right? Like I'm trying to put them together. The oxidation model, oxidation ladder is one that people talk about, but
Sure. Yeah.
I
Yeah.
I am trying to create them in a sense too. So I part of it is like me trying to figure out how to explain to people. I don't like already have everything written out, right? That's not where I'm at with this part. It
Yeah.
is a lot
Wouldn't
of
it be great
exploration.
if that's how it actually worked? You know what I mean? Where you're just like, well, this is like my master plan. Like explaining, but that's never how it goes. You're always like halfway through writing something, you're like, oh shit.
Every time I think so I sent you a draft of what I'm sending tomorrow or whenever that this goes live.
Yeah.
It's like probably 80% different. Like it's not at all. I was up at like 3 a.m. last night. No, not that. Like it's just constantly just like no, that's not the way of saying it. That's it's a iterative process for sure.
Yeah. Well, why don't you give me a little preview of this thing that's coming out? By the way, everybody, check the show notes again, Feedstockland for the Substack, so you can go read these pieces. But what's
Appreciate
this? Yeah, of course. I'm gonna plug you as much as possible, man. You're taking time out of your day to talk to me. Um, why don't you tell me a little bit about this piece you have coming up?
Yeah. Well, I think right now, basically, like the idea that I've built up so far is like we're looking at reactions strictly in terms of how much energy they consume or release, right? And that's one problem. Like if it's consuming energy, now we've got to deal with these emissions, right, from
Mhm.
driving the reaction with heat. The extra issue that the chemical industry deals with is that whenever you're doing molecular transformations, right? Your level of control is a lot different than the amount of control you have when you're like assembling a truck or something, right?
Hmm.
The truck parts go together one way. You're not going to put together a truck and end up with a Miata. Like it's
Hmm.
it's going to be a truck. When you make chemicals, okay, it doesn't work like that. Like you can try your best to make the one you want, but we don't have that good of control. And this is what catalysis is really about, right? It's
Mm.
conversion, selectivity, these sort of terms. What I'm trying to introduce with this next piece is two elements of kinetics, right? Just like the fire, when you want to get started, you have to give it a little bit of energy, right? Bonds are stable in their like natural in their state that they're in right now. If it's not reacting like in like while you're looking at it, it's not going to start randomly reacting. You've
Hmm.
got to do something. So that's the first bit. And the second bit is that speed matters a lot. So like
Mm.
in a chemical process, it's not just like five parts go together and you get one thing out. It's like you have two reactants, right? And they don't just combine in like one way. They can combine in three ways. Or maybe you've got like four reactants. I don't know, right? And then those things make stuff. And then
Hmm.
you got those products, and then those products react with the reactants. Like you've
Hmm.
got this hodgepodge of things going on. And so even if like a reaction, say you've got one reaction that's like going to release a lot of energy. You're like, great, this is not going to be energy intensive at all. I'm going to make that one happen. You're forgetting that like other reactions happen at the same time. And so the
Hmm.
one you want to happen, even if it's energetically favorable, might not happen. And I think, this sort of thing is often conflated with like why it's hard to utilize CO2, right? We
Mm.
can use CO2 to do certain things. We do have like polycarbonate, polyols. I think, there are these polymers that we can make with CO2. There's stuff you see, people do it. It's not like impossible. It's just that a lot of times the what you want to do is also in the mix of things that you don't want to happen in the same reactor. Um,
Hmm.
anyways, I write it out a little clearer
No,
in the
I
post,
actually,
but that's
I
the
actually
general
think
sense.
that's great. I think that that was a nice little peek behind the curtain because I think for a friend of the show, Isaac Orr, grew up on a dairy farm in Wisconsin. Now he does energy analysis. He still lives in the Midwest. Love that guy. He's a very funny dude, and he was always like, "You want to know why I don't like people like you?" He's like, "Because you're from Illinois, and you're from the suburbs." Now, the only relevant part of this is that I'm from the suburbs. Football fans will know why someone from Wisconsin feels that way. And I was like, "Why?" And he's like, "Because you think milk comes from the store." Which is
Yeah,
like the
a lot of
perfect thing
ambiguity
for,
there.
yeah, it's like the perfect thing for a dairy farmer to say, you know what I mean?
Oh
um
yeah.
and because there are a lot of things that can happen with the thing that you want while you're doing that aren't what you want, and people who are downstream from that have no idea about the chaos of that. I am totally outside of that world, and I'm going to be totally honest, it never really dawned on me. Like, I knew there were accidents that could happen and stuff like that, but the level of precision that I assumed was not what I saw in the draft of that piece that you sent me. I was like, oh, so it's sticky, like even now. Like, that's just an inherent feature of doing this.
Ah, yes. Yes, it is. It's not like it's impossible in theory, right? Like enzymes are kind of like the holy grail of catalysts. They're just like
Mhm.
infeasible to produce exactly the ones we want. But in a way, right? Like enzymes they are allowing one reaction to happen and exactly the one you want to happen. So, I mean, there's cost conversion issues, all sorts of things, but yeah, there is inherently we have this big issue where we have a really hard time making reactions do exactly what we want them to do.
And so what does that mean for the industry? Like, what does that mean for chemical companies? Like, what are is that a safety issue? Is that an economic issue? Like, what type of problems are like
Yeah,
sort of knock onto that? Why don't you tell me
no,
about that?
I mean it's an economic issue. It's you when you make something you don't want to make along with it, you need to deal with it, right? So like like are you familiar with say BASF's like giant Verbund in Germany? Like they have these
Yeah,
like enormous site.
aren't they moving out of Germany right now in a large part because of the energy costs there?
Yeah, you know, that is definitely a thing. I
Sidebar.
think they're definitely downturning a lot of stuff. But yes, sidebar. I think yeah, basically the kind of lost my train of thought there though.
So you were going to talk about like what they have to do. They have to handle this stuff that might
Oh
not be what they
yes.
want.
Well, I mean, so yes, that's what I was getting at. Like, why is that site so enormous, right?
Hmm.
And the site is enormous because when you make one chemical, you're like, okay, I got like 80% of what I wanted, but now I got this other thing to deal with. And it's like, what do you do with that? Like when the chemical industry started, we just dumped that. Like we don't do that anymore.
Yeah.
So we don't dump it, right? We try to figure out ways to use it. And so it just ends up being this like sprawling mess of like, oh, now you're gonna catch it here and like catch it here. And so it's like no one can develop like a very capital efficient process to produce the one thing you want. You have to like buy all this equipment and have this enormous site just to do the one chemical you wanted. Like that's, I mean, you really ideally, no one really wants to start from the, you know, the building block material and have to go through 50 steps to get to the thing downstream. Like ideally you just kind of, you skip the whole value chain, but that's not how it works. So, you know, it basically ends up making the industry like very expensive to build stuff.
I was about to say that's like capital intensive. It seems that seems to encourage a certain level of vertical integration for a lot
Definitely
of
does.
reasons, like operationally as well as economically. To keep that going, it almost makes me think of like a theme park where it's
Mm,
like, people will describe parts of a theme park as like, okay, so Disney World has 4 parks, right?
right.
And Animal Kingdom is generally called a half day park. And that's bad, right? Because you want everything to be a whole day park because that means that people are staying there, they're buying the food, they're getting all of the other things you want to have happen or every other thing that you could use needs to make sure that it's using every single part of the day. And it seems to be sort of
Interesting.
what you're telling me with in terms of how these chemical processes happen, where like, sure, you can't really just dump it anymore. And also you can make money off of not dumping it. So you can't have a chemical plant that's a half day park. That thing needs to be a whole day park.
It has to be. That's exactly right. Yep. And I think that's, I mean, that kind of, this will eventually lead to like, right, like the big complex thing. It's all about like the third element of the third basic thing to get at with this, you know, like your chemical industry 101 is the separations processes. So, you know,
Mm.
this is like, how do we, like, so we got this mixture of stuff, like now we need to separate it. And it's like about recycling things and then using it elsewhere. So it ends up becoming, that's kind of like the third component is like how we end up dealing with the inherent issue of not being able to be a full day park.
Yeah, I mean that's a fascinating problem to solve. And it's not one that I think the public is really privy to. Because like you
No,
said, when GM or when Ford makes an F-150, like they're doing that the whole time, you
oh
know?
yeah, definitely. No, it's, I mean, we put chemical plants far away from like where people live for the most part for good reason. Like, you know, as you've seen, like accidents do happen. And you know, because of that, like it is kind of out of sight mind. And when you're driving between places and you see like enormous plants, you're not like thinking about like, why is it so large and integrated? You're like, what is that thing? And like, why is it spewing stuff? Like that's about as far as the thoughts I think go with, I don't
Yeah.
know, you know, the bulk of people, but
Yeah,
can't speak for
that's
everyone.
how my thought process used to be. Like I was totally thinking, I used to absolutely think like that. And then I remember driving by some energy infrastructure with my wife, and I was just like, oh, like that's a coal plant. And then you can see like this other thing next to it. And I was like, damn, 2 years ago, like I would have been like, that's a lot of metal. It seems
Oh
like got a
yeah,
lot of metal going on there.
lots of metal. No, you can't really, it's hard to disambiguate without like a little bit of information about, I mean, even say like just being able to pick up that like it's a coal plant where you see the conveying, like the conveyors, right? That's all you really need to pick it out.
Yeah,
People, I mean, in your background, like these giant like sorry,
steam towers.
core
Yeah.
loops, yeah, steam towers, like the people associate with that with nuclear, but it's not just nuclear that has those things, right? That's just kind
No,
of what people are stuck with that image in their mind that that's nuclear. But
that's
cooling towers
largely, I
don't
think,
have
because of
to
The
be.
Simpsons, like because that's in The Simpsons plant,
Interesting.
Mr. Burns' plant, it is those like the sort of like hourglass shaped
Mm.
steam towers, right? Like that's why I thought that that was strictly nuclear.
Yeah, actually, I did a little bit of research on this, and I'm probably not gonna remember exactly, but there was some sort of bill or something was passed that changed it. So there's like a set of nuclear plants or a set of like power plants after a certain date started having these and previously didn't. I don't know
Mhm.
exactly, but maybe you find interesting.
Yeah, yeah, I should probably look into that. So, um, let me ask you like another question. Like, who's your ideal reader for Feedstockland? Tell me that, because that's a yeah. I love your reaction already because like people asked me that, and I'm just like, buddy, the people who read it.
I don't know. I think I would probably call them like the like generally curious community.
Hmm.
A lot of the reason, like I'm a big Beehive fan for sure. The reason
Hmm.
I went to Substack was because Substack has this like already like very large audience of individuals with long attention spans. And like that's kind of what I'm
Yeah,
going after. Like someone
that's
who
a
will, yeah,
that's such a great point because like the UI for Substack really lends itself to that. It's not just the community that's there, which is there, you're right.
right,
Um, but in Beehive, where our other newsletters run, because we're that
right.
we're those types of guys, are way better for if you're just doing like under 1K words, like here's what's up, like here's what you
Oh
need
yeah.
to know, you
Oh
know.
yeah.
And stuff in Substack that looks weird. It's like, why
It
is this so
just
short?
Yeah, no, there's a natural shareability aspect of it, right? Like I've been writing the column for 3 years. No one's ever asked me to do a podcast, right? I write one article on Feedstockland. There's a sense of like you can do news updates, and that's interesting and useful, but it's mostly interesting and useful to people that are like really in the industry. It's not
Mhm.
enough to really like spark conversation or do really much with it. So platforms like Beehive are great for, like that kind of audience, but yeah, if you want to like reach a broad audience and like start like educating people broadly about something that they probably should learn about, but maybe aren't in it, like that's the kind of way of doing it. So
Yeah,
I don't know. I
yeah,
don't know who they are, but I imagine there are a lot of like your listeners or probably a subset of Doombergs. There's just like there are people that talk about this stuff every once in a while on the internet,
yeah,
and I hope that it strikes a nerve with people. A lot of the energy people for sure.
yeah, for sure. I mean, I'm definitely fascinated in sort of being on the journey of getting more feedstock land in my inbox. You know,
Cool.
like I want to figure this stuff out. I'm sure a lot of my listeners will. And so before we sort of wrap up here, like where can people reach you other than here? Do you have a Twitter? Do you have any place? And by the way, people, I will also put that in the show notes so that you don't have to type it in yourself.
Yeah, no, I mean you can find me on Twitter. It's Yeah, you'll find it on the description. Um, but website wise, I operate Feedstockland on Substack. You can give it a search there, or the link down in the description. And same thing with the column. If you really want to stay up to date on all the happenings of the broader chemical process industries, like be my guest. Like come learn.
Yeah,
I
hook it
write a
up.
very broad spectrum of topics there. Like I might talk about sulfur processing one day and then plastic recycling the next, and then some sort of obscure chemical that you'll probably only hear about one time in your whole life the next day. And so it's it's fun, but I mean that's kind of the ways to reach me at this point. Just kind of ramping up.
Great. Great. So everybody, I've already told you enough times. Go check out Darius's stuff. Darius, thank you for joining me. And everybody, stay strong, stay sharp, and stay radiant. We will see you next time.